Today we'll discuss the relationship between visual fraction models and equations. But in order for us to do this, we must first understand the term reciprocal. The reciprocal of a number is taking its numerator and denominator and having them switch positions. So the reciprocal of 5/9 would be 9/5. Notice we took the numerator and moved it to the denominator's position, and took the denominator and moved it to the numerator's position. So then the reciprocal of 11/4 would be 4/11. So what would the reciprocal of 142 448ths be? Yeah, we simply switch the denominator and the numerator, and we have 448 140seconds. And now that you know what reciprocal means, I'm going to tell you that it has another name, and that is inverse. In fact, we're going to talk about the multiplicative inverse. Multiplicative inverse is made up of two words, multiplicative, which deals with multiplication, and inverse, which you already know is reciprocal, which is switching the numerator and denominator. So, 3/4 inverse would be 4/3. Okay, we have the inverse or the reciprocal part, but what about the multiplicative part? Yes, again, multiplicative is dealing with multiplication. So, when we say multiplicative inverse, we mean flip a fraction and multiply it. So instead of 3/4, we now have 3/4 multiplied by 4/3. The neat thing about the multiplicative inverse is that it will always, I repeat, always equal 1. Wait, so you're saying, Mr. Weichert, that 22 564ths multiplicative inverse will equal 1? Well, let's find out. First, we create the inverse, which would be 564th 20seconds, and we multiply it. What do we get? 1. Now, if you did the math and multiplied 22 times 564, and then multiplied 564 times 22, you would come up with the same number. Let's go back to the 3/4 multiplicative inverse. Take a look at this. If we actually multiply this out, numerator times numerator, denominator times denominator, we'd end up with 12/12. 3 times 4 is 12, 3 times 4 is 12. Now, what is 12/12? Well, remember, fractions always tell us how many pieces are chosen out of how many pieces make a whole. So, if I have 12/12, I'm really saying that I have chosen 12 pieces out of 12 that make a whole. So really, I've chosen the whole thing. And we call the whole thing, if there's one of them, 1. One whole thing. So 3/4 times 4/3 is 12/12, which is equal to 1 whole. Now it doesn't matter what numbers we have as numerators or denominators, when we have the multiplicative inverse, the product will always be 1, because the numerator will be the same value as the denominator. So remember this crazy problem? What would 22 times 564 be? If we multiplied the numerators and denominators, we'd come up with 12,408 12,408ths. Now, if I'm choosing 12,408 parts out of 12,408 pieces that make a whole, then I've just chosen the whole thing, which is equal to 1. I want you to take a moment now and write out your own multiplicative inverse example. Another way that we can say the multiplicative inverse without using numbers is to use variables, or letters that symbolize any value. So if we have some value, and let's call it a, and another value b, and we set up a fraction like this, then its inverse would be b over a. You see how I switched the numerator and denominator. Now, multiplicative inverse means that we need to multiply them, and we've learned that when we multiply a multiplicative inverse, the inverse of the fraction we're using, we come up with 1. Now, this formula is important because using a and b, we can plug any value we want to for a and any value we want to for b, and it will always equal 1 using this formula. But Mr. Weichert, I have a question. Who cares? When will I ever use this? Ah, I'm glad you asked. Let's take a look at some fraction division problems again. Here's one, 3/4 divided by 2/5. Remember the two different interpretations of division, measurement or partitive? Well, we need to choose one. Let's go with partitive for this problem. So using partitive division, we could say 3/4 is 2/5 groups of what size? And so I draw it out, and here is 5/5. Now we don't need 5/5, but we're dealing with fifths. Remember, 3/4 is 2/5 groups of what size? And so here is my 2/5. Now because our partitive interpretation says 3/4 is 2/5 of what size, I can rewrite that 2/5 as 3/4. And looking at this model, I can see that I have two parts that equal 3/4. That means if I take 3/4 and cut it in half, I will have the value for each of these two parts. So how do I cut 3/4 in half? Well, I want half of 3/4. So 3/4 times 1/2, and 3/4 times 1/2. And 3/4 times 1/2 is 3/8. So I have 3/8 and 3/8. And this is helpful because it tells me what the value is of every other fifth here. All of these fifths are equal to 3/8 individually. Now, let's not forget the problem. 3/4 divided by 2/5. Remember, we first rewrote it as a partitive interpretation. 3/4 is 2/5 groups of what size, and we divided our model into fifths. And then we labeled the 2/5 that we're dealing with. Unless we keep working with words, the translation of 3/4 is 2/5 groups of what size would actually look like this. 3/4 is, remember is the same as equals, 2/5 group, group is always multiplication, of what size? Put a question mark. What we did next is we changed the 2/5 label to be 3/4. Why did we do that? Because our problem says 3/4 is 2/5. So we can replace it with 3/4. And then because of our model, we recognized that we could divide 3/4 in half to get the value of each of those fifth units. So 3/4 divided by 2, which we found to equal 3/8. Because we figured out that each fifth is worth 3/8, we filled in the rest of the fifths with our 3/8. Now, if the question is 3/4 is 2/5 group of what size, we want the size of the whole group. And so we have 3/8, 1, 2, 3, 4, 5 times. 3/8 times 5, which is equal to 15/8. Okay, now without the model, let's look at what this would be like on paper. 3/4 divided by 2/5. That was our original problem. Picture what we did with the model. First, we had those 2/5, but we said that they are 3/4, and there are two of them. So we needed to divide it in two. So we did that first. After we found out what 3/4 was divided by 2, then we needed to find out what the whole group was, and there were 5 pieces. So we needed to have that quotient multiplied 5 times. Take a look at this written down. 3/4 divided by 2/5 was the same as 3/4 cut in half or divided by 2 multiplied 5 times. Now the crazy thing is, we could rewrite it another way. 3/4, we wanted to have it 5 times, but we wanted half of that. Remember, we cut it in half. So, it is completely correct to say that 3/4 divided by 2/5 is equivalent to 3/4 times 5/2. And this, if you notice, is exactly what we were talking about at the beginning of our lesson, the multiplicative inverse. Look at 2/5. Is it okay for us to say that dividing by 2/5 is the same as multiplying by 5/2? Yes, we showed it in a model and we've showed it here on paper. The multiplicative inverse. Okay, let's try another one. 3/5 divided by 1/4. This time let's use the measurement interpretation of division. So 3/5 is how many fourths, or how many fourths can we take out of 3/5? Let's first do a model. So I need 3/5 and I need to take out fourths. Here's my 3/5. Actually, there are 5/5 here, so we need to select how many of them? 3, because we want 3/5. Now, we want to know how many fourths there are inside of these 3/5. Personally, I don't know how to take out fourths from fifths. That's like taking apples from a bag of oranges. I can't do that. I don't see fourths nice and easily here to take out. So instead, I'm going to have to make my fourths and my fifths be the same denominator. In this case, I'm going to choose 20. Both 5 and 4 are factors of 20. And so 1/4 would be equivalent to, let's see, 4 to 20 would be 4 times 5. So I need to do my numerator, 1 times 5. Oh, 1/4 is equivalent to 5/20. So the question really is, how many 5/20 can I take out of 3/5? I can't take 20ths out of fifths. Oh, but that's not what we were going for, remember? We also need to change our fifths to be 20ths. So, 3/5, how many 20ths is that? Aha! So instead of saying 3/5, I can now say 12/20, because 3/5 is equivalent to 12/20, and now I can take out 20ths from 20ths. The question now is, 12/20 is how many 5/20? And so, let's count off 5/20. 1, 2, 3, 4, 5, label that purple group. 1, 2, 3, 4, 5, label that a red group. 1, 2, 3, uh-oh. We don't have enough for a third group. And so we notice that we only have 2 parts out of the 5 that make a whole. Well, let's label those as well. Okay, so what is our answer? How many 5/20 can we take out of 12/20? Well, there was 1, we labeled that with purple. And there's another one, so label that with red. So far we have 2 groups of 5/20 that we can take out. But what do we say about these 2 green parts? Remember, it's not enough to be a whole group of 5/20. It's only 2 out of the 5 pieces we need. Oh wait, it's 2 pieces out of how many make a group? 5. Remember, we're looking for 5/20, and we only had 2, so that's equal to 2/5. Lest we've forgotten the entire original question, let's go back to that. 3/5 is how many 1/4, or 3/5 divided by 1/4? Well, we see 1 whole, 2 whole, and 2/5. So 3/5 divided by 1/4, we've shown in our model, equals 2 and 2/5. Notice what this model also shows. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. We have 4 pieces, or 4 parts, 3/5 times. Remember, the whole thing is fifths, and we've chosen 3 of them, 3/5. And if we look inside of each of those 3/5, there are 4 parts. So that's the same as saying 3/5 times 4, which is equal to 12/5. And 12/5 turned into a mixed number is equivalent to 2 and 2/5. That's the same exact number or value that we got for our quotient when we said 3/5 divided by 1/4. Remember, 3/5 divided by 1/4 is 2 and 2/5. But the model also showed 3/5 times 4 is 2 and 2/5 as well. Okay, let's try another. 2/3 divided by 3/4. For this problem, I'm going to decide to use measurement interpretation of this division problem, so it'll be how many 3/4 are in 2/3. So my model would show 2/3. And here are 2 pieces out of 3. Here's my 2/3. But my question is, how many 3/4 are there in these 2/3? And so I can label it like this, how many 3/4? Now, because I know that I can't take fourths away from thirds, that's again like taking apples from oranges, I'm going to change my fourths to be something that I can deal with thirds, and that will be 12ths, because I know that 12 and 3 are related. 3 is a factor of 12. And 3/4 is equivalent to 9/12 because 4 times 3 is 12, so 3 times 3 is 9. And my question now becomes, how many 9/12 are there in 2/3? Now, the 2/3 is still a problem because I can't take 12ths away from thirds. And so I'm changing my thirds to 12ths, and I come up with, let's see, 3 times 4 would be 12, and so 2 times 4 would be 8. 8/12. So my question now is, how many 9/12 can I find in 8/12? Oh no. Notice again that we have 8 pieces shown or selected, and we're supposed to take a group of 9. That's 1 more than we have. So can we even take a whole group of 9/12 away from 8/12? No, we can't. Instead, we can only take 8/12 away from 8/12. But what is that? That's 8 pieces out of how many did we need? 9. We needed 9/12, but we could only take 8 because there are only 8. So it's 8 parts out of 9, 8/9. That's the group of 9/12 that we can take from 8/12. And let's not be confused here. Our original problem was 2/3 divided by 3/4. We decided to interpret that as measurement division. So we said, how many 3/4 are there in 2/3? Well, we recognized that thirds and fourths are different, so we changed them both to 12ths. Then we said, how many 9/12 are there in 8/12? Saw that we can't even take 9/12 away, but that we could take 8 out of 9 pieces away, 8/9. What would this look like if we did use the partitive interpretation of this problem? 2/3 divided by 3/4. That would be 2/3 is 3/4 group of what size? Okay, so I can draw my 3/4 because my question is 2/5 is 3/4 group of what size? Here's my 3/4, but because we're saying 2/3 is 3/4, my 3/4 that I can see, I'm going to label as 2/3. Now, because there are 3 pieces, we need to take our 2/3 and divide it by 3 if we want to find the value of each part. So 2/3 divided by 3 is the same as saying 2/3 times 1/3, right? We want 1/3 or a third of 2/3. So 1/3 times 2/3 is 2/9. So now I know that every piece of these fourths is a value of 2/9. Written out on paper, 2/3 divided by 3/4. Multiplicative inverse of 3/4 would be multiplying by 4/3. So 2/3 times 4/3 is the same as saying 2/3 divided by 3/4. This makes our problem nice and easy because multiplying fractions is simple. Multiply our numerators, we get 8. Multiply our denominators, we get 9. 2/3 times 4/3 is 8/9. That is a lot quicker than having to draw out all of our pieces and find an interpretation of division. All we needed to do was multiply the inverse of the fraction if we were being asked to divide. And that's our summary. Dividing by a fraction is equivalent to multiplying by its reciprocal, or the multiplicative inverse. And by the way, did it matter which interpretation, partitive or measurement of division that we used? Did it matter? Lastly, a formula that we can use to show what we've done is this. Say we have 2 different fractions and we're being asked to divide them. AB divided by CD. And now, using what we've learned about reciprocal and multiplicative inverse, we can say that A over B divided by C over D is equivalent to A over B times D over C.